Hey, so the next talk is by Burr, Sutter, 12 A's of the Cloud Native Warrior.
All right, you guys ready? I know you guys have been sitting in sessions for a long time, and everybody's kind of exhausted and thinking, I have too much information in my head already. And here's this guy who talks too fast going to talk to us one more time. Well, Josh talks really fast, but I'm not nearly as funny as Josh. Now, here's the challenge with this presentation. When I originally pitched the idea of this presentation to the organizers, it was a 3-hour presentation. Seriously, 3 hours. And right now, we only have about 45 minutes or so. So we're going to have to move really fast to cover the same ground I would have covered in 3 hours. Just so you know, I actually run a lot of different sessions with O'Reilly, and so that's where this idea came from. So I run a 3-hour session on Istio. I run a 3-hour session on Knative. And so I was going to include a lot of those 3-hour sessions into this one 3-hour session. But we're going to have to move fast today, so let's do that. Okay? And I have a Bruce Lee theme. Notice the slide deck is available here at bit.ly 12 Ways Cloud, so at the bottom there. So make sure you get that information so you can check in. You can check in to that bit.ly 12 Ways Cloud URL down there. That'll get you access to the slide deck. So let's get started. I have a book you can download if you're interested in Istio Service Mesh. I'll quickly introduce the concepts. I know there's a breakout session earlier today on Istio, so everyone here is already educated on Istio. I'll just show you my perspective on it to give you a little feel for it. But also, I want you guys saw Knative yesterday, actually, in the Quarkus talk. I showed you serverless Kubernetes. So we're going to cover some higher level ground today, since I kind of already did the Knative presentation. We've already done the Istio presentation. I'll talk to them again briefly, but otherwise I want to show you something else completely different around the hybrid cloud. And we'll show you that actually pretty quickly, okay? So there's a recording of my intro talk. If you actually, how many people here are new to Kubernetes, have not tried Kubernetes yet? Okay, so the rest of you already have Kubernetes experience. Fantastic. So if you're new to Kubernetes, I highly recommend going to this talk here. It's a 3-hour recording from DevOps Belgium. It'll walk you through a lot of the introductory concepts of Kubernetes specifically. Now, here's a key question I want you guys thinking about as it means becoming that cloud native warrior, become that cloud native developer. Do you work for an organization where custom apps and APIs are key strategic advantage for your company, for your project? Or do you work for an organization who looks at you like a cost center and something that's too expensive? Now, here's the good news. You're at this conference today on a Saturday. That means you chose to use your own personal time, and I really respect that. Not too many developers in this world will do that sort of thing. There are approximately 10 million professional software developers on the planet, meaning they get paid to do software, and yet we have less than 0.1% to show up for their local Java user group, local meetup, their local event like this one. So already you are the elite of the world's elite, because the other 7 billion people on this planet, they want what you have. You have the ability to create magic with your fingers. Think about that for a second. You can create digital assets, whatever the digital creation might be. It might be just simply a new video. It might be a new piece of music. It might be an API. It might be an application. But the reason I asked this question right here is you want to work for the former, not the latter. Anybody who thinks you're too expensive is the wrong company to work for. Just keep that in the back of your mind, okay? All right, so this is your journey to awesomeness. You guys have seen this from me in previous presentations, and it looks something like this. You got to start with DevOps, okay? DevOps is super critical, and we'll talk more about DevOps. You got to think about self-service and on-demand elastic infrastructure. We'll talk more about that as well, and we'll see some of that. You got to think about automation. No more feeding CDs into CD trays. No more SSH into a box and doing a yum install this and yum install that. Fully automate everything so that you can burn those servers to the ground and recreate them easily. And of course, with a Kubernetes architecture, it's easy. Think about your CI/CD deployment pipeline, right? No more deployment pipeline on the whiteboard. No more deployment pipeline on the napkin or in a PowerPoint slide. Take all that off the PowerPoint slide and put it into code. Okay? A Jenkins file is super easy at this point, right? It's just a Groovy script, and you can automate the full deployment pipeline. Then you should think about your advanced deployment techniques, and I'll show you these with Istio capability. So what is a blue-green deployment? What is a canary deployment? What is a dark launch? Those are super easy with an Istio-based architecture. We'll show you those. And then, of course, you then are ready to be also awesome with microservices. Now, this is my Bruce Lee version of this. You probably have seen my evolutionary version of this with, amoebas and things like that. But I have other versions of this, too, because I've done this so long. I have the Teaching Elephants to Dance presentation, where I talk about these same principles, but I also talk about it from my Wonder Woman superpower standpoint, too. So I have a lot of fun with this particular evolutionary concept, because here's the idea. We are all on a journey, and we're all here to learn. You're here to learn on a Saturday. I'm learning all the time just by spending time with you, and we're always trying to get better at our software craftsmanship, how to being a better software developer. So these are the 12 ways, and again, I expected to do 3 hours of this, so we're not going to be able to do all this today. But if you think about it, DevOps is certainly still number 1 on my list, so we'll talk about that briefly. You've got to be thinking in those terms. It's a different mindset and a different culture, and I'll try to explain that visually when we get into that part of the presentation. But I also want you to think about your skill portability. Okay, the skills that I created, and one nice thing about Java, the reason you chose Java is so you could be skill portable. Your code may or may not be 100% portable. Normally it is, but you're skill portable. You can move from one application server to another application server. You can move from one Linux to another Linux. You can move from Windows to Linux. You can move from Linux to Solaris. Not that anyone has Solaris anymore, right? But you could. You could do those sorts of things if you wanted to. So be thinking about all these principles. We're going to touch on them very lightly. There's some key ones here, though, that are interesting to me. Consider your application architecture versus your application infrastructure. And as a software developer living in this cloud-native world, you have to understand the full stack. And I don't mean the full stack just down to your web application server, which is how most people think. I mean the stack below the application into the application-level infrastructure. Because now that's starting to matter more than ever before in a cloud-native world, okay? Yes, we'd like to abstract you from it. Yes, you'd like to kind of ignore it. But I'm here to tell you that developers also have to think like operators. All right, I recognize that most people don't have that message, and they don't tell developers this, but this is what I'm telling you today. Start thinking in terms of full stack all the way down to the infrastructure, because it's the infrastructure that will burn you. It's the infrastructure that will break your application. It's the infrastructure that will cause you to get woken up at 2 a.m. in the morning when stuff's not running. And that's where we have to go as developers. So we're going to talk about these things, but let's go ahead and actually think about one principle here. I like my Bruce Lee quotes. Adapt what is useful, reject what is useless, based on the 12 bullets I already gave you. Feel free to reject what you don't like in the list that I gave you, but add what is specifically your own. All these principles are just simply things that you would add to your own personal life. But I want to show you a demonstration real fast, and this is about skill portability. The reason, if you read the abstract for this session, I talk about the fact that Kubernetes is now the de facto standard for the cloud. And that means the public cloud and the private cloud. That means the hybrid cloud and the multi-cloud. That means if you're interested in this cloud-type architecture, then you can go to the Cloud Native Computing Foundation and find out about this thing called Kubernetes, and then you have skills and code that is fully portable, and that's what this demonstration is about. So let me show you this, and I'm going to need your help. Get your phone out. You guys are going to have to help me with this, and we're going to blow it up. So let me try this. We're going to go to a certain URL, and I'll go ahead and put that in here. So go to bit.ly hybrid cloud 3 on your phone. So go ahead and type that in. Yeah, let's put this over here so you can see it. It's going to give you a user interface that looks like this one. And I can do things like type 1 and 2 and 3. I'm just pushing messages in. So you guys will have to help me with that. Anyone get to the URL yet? bit.ly hybrid cloud 3. Push messages into this user interface. Because what it's doing is the user interface is sitting up in a Kubernetes cluster on Amazon right now. That's where that user interface sits. And because it's on Amazon, it's processing the transactions on Amazon, okay? But that doesn't have to process the transactions on Amazon. We'll show you that in a second. So let's see if someone can join me here and type in a message for me. I'll see your message if you're successful. So 4. There we go. Now we got some people coming in. Okay, those are obviously not all my messages. All right, now here's the trick. I'm going to go now into my user interface. Oh, no, by the way, I have this over here running too. So I can see that most of the transactions are happening on Amazon right now. That's really what that's telling me, okay? But let me come over here to this user interface, and I want to show you this. Here's my Amazon user interface. As a cloud-native developer, someone who wants to understand the infrastructure, I got to learn this environment, and I can. I have. I run a ton of things up on Amazon as an example, but you have to decide how to launch those VMs yourself, how to get the right infrastructure you need on your virtual machine. But at the same time, I've also got Google. My Google one is running in India. My Amazon one's running in California. My Google cluster is running in India. Because I can be now multinational. I can go anywhere across the globe, whichever gives me the lower price or lower latency. Lower latency for my customers in Asia versus lower latency for my customers in Europe. Okay, so this is also in California. This is my Azure cluster. And then I also have one over here that is actually in Frankfurt, here in Germany. Okay, so basically I basically have data centers across the globe now, the same application deployed across all of them. Here's the one for Amazon, here's the one for Google, and here's the one for Azure. So the exact same application running across the entire globe. That's kind of the point of this demonstration. But let's try this. So you can see people have been pushing in some messages there. What I want to do now is go to my Amazon one and turn it off. And basically, I'm going to turn off its local processor. So we're going to just shut it down. And let's bring this back up again. Okay, so let's go Burr. All right, you can see right there, now it says Burr. And notice what happened. You failed over to the Burr cloud away from the Amazon cloud, including all the transactions you guys are pushing in right now. Okay, so it's just like that. Just because the workload processor basically was turned off, now the whole application logic, if you will, the transaction logic is moved to another cloud. Let me go shut down Burr, actually, kind of make this a little bit more interesting. And of course, you notice Burr looks a little bit different because I have a different version of Kubernetes, a different version of OpenShift here. And you can see now, we're all on Google. On Google. So we just failed over from Amazon to Burr, which was in Germany, to Google, which is in India. And notice, see that little bit of Azure right there? That's because this actually is being very clever. It recognizes there's more latency going to India, and every now and then it sends a transaction to Azure. But if I turn off Google, let me come over here and shut down Google now. And let's do that. All right, kill that one. You'll see that everybody goes to Azure. Where is this one? Okay, and there's Azure. So the concept is very straightforward. My application, my skills are 100% portable. Because I know Kubernetes, I can deploy apps across any cloud, anywhere on the planet. I get the best price for that compute cycle, and I get the lowest latency for my customers. Latency is what matters. If you have customers in Latin America, you don't want a data center in Europe. If you have a customer in Singapore, you definitely don't want a data center in the US. By default, a transaction coming out of Singapore back to the US adds 200 milliseconds per transaction. I've measured it myself by flying between the two places and testing that. So you want to have low latency, but let's actually do this real quick. I'm going to turn this back on. Let's bring Google back online. Let's bring Amazon back online. I'll even bring Burr back online. All right, this one right here. Let's bring them back online. You'll notice that here Azure was the only one running. It processed 4,000 requests so far with 0 errors. But as the other processors come online, you'll see them pop in here. So one more time, we'll see, okay, we're back on Amazon now. That's good. Google's coming online. But let me do this. I'm going to basically now change the load, because I can actually spray load around this. To actually, we have a load generator, because you guys can't pump in enough messages fast enough. Let me bring up the load generator and watch what happens. So you can kind of see what's happening now. We have a load generator starting up on Amazon, and you'll see that even if there's a tremendous amount of load, it processes it locally. Okay, so 2,000 transactions per second there, 2,600, 27,000, so almost 3,000 transactions per second because it's all on Amazon. The load is on Amazon, the transactions are processed on Amazon. But again, if I kill that Amazon worker again, this one over here, shut down. And then again, we still have our Google one, we have our others, but let's go over here. And you'll see what's happening. Now, notice most of the transactions are happening on Burr. And if I shut down Burr, one more time, okay? So if you think about serverless style architecture, basically I want to put my compute cycles wherever they belong. Meaning I don't want to pay for VMs I'm not using. And so in this case, I literally am shutting down pods in the case of Kubernetes. I'm shutting down those machines in the case of Kubernetes. I don't need that workload there anymore, and I can route it over to Google now in Azure if that's what gives me the lower latency and better price. So this is a simple concept, but this is about skill portability. Once you master Kubernetes, you can take your application anywhere. Does that make sense to you guys? Was this a cool demonstration to show you? All right, you guys got a chance to play along here and probably put something horrible in these names. Did you guys do that? I wouldn't know. You guys played nicely, though, because it could be that you'll do something horrible in that case. And actually, I can come over here and shut it down so you guys can't even play with it anymore. Let's do that. This is the web front end, and we'll just close it down, so now you won't be able to send me any more messages. There we go. Turned it off. All right, let's get back into this now. I wanted to show you that, though, to kind of give you a feel for what it means to be cloud native. All right, let's jump into this and kind of do some fun stuff. We have another demonstration coming up, so be ready. Now, Here's my story about DevOps. We think as developers that we didn't have to we could write code, we could compile code, we could build code, and then we no longer had to run code. And the reason I think that's a broken mental model, and a broken model for all the organizations you probably work for today, because most companies have a DevOps team, don't they? Most banks that you work for, most telecoms that you work for, most insurance companies or governments that you work for now have a DevOps team, and almost none of them have developers on the DevOps team. It's just ops. And that's a problem. It's a problem because we still think in these terms. We have these two silos, dev on one side, ops on the other, and we think we're supposed to throw our code over the wall. We think it's supposed to look like this. But I can tell you, when you first learned how to program many, many years ago, for some of you it was only 2 years ago, for some of you it was 20 years ago, and in my case it was 30 plus years ago, the first thing I did after I typed the code in and saved it, I compiled the code, built the code, and then I ran the code. And we had great joy when we saw our code run. We actually liked it so much we probably told our mom or dad. We told our friends. We told our teacher. Whomever it was sitting nearby when we actually got that code to run, we were excited. And when we separated the code side from the run side is when we broke the whole model. What I'm advocating for is developers see their stuff run again. Make it run. You build it, you own it. That is the new philosophy in the cloud native world. That's one of the things you see coming out of Amazon and Netflix and places like that. You're now a part of a 2-pizza team. So you want to work in a world where it doesn't look like this, okay? This is software development in most large organizations. It's a big amorphous blob with a gang of people all pushing on this blob, trying to push the stone uphill. Have you guys heard that expression before? Push the stone uphill? Roll the boulder uphill. When I was in Australia, they said, no, we call it pushing shit uphill. That was exactly their quote. There's like, if you say that here in Australia, we'll know exactly what you mean. But here it is. Here's this amorphous blob. And check out this one right here. Who is this person? You guys are developers. Who is this person? Is this your operations team? Someone's going to say that. Someone more clever will say, no, it's the security team. Somebody thinks it's their job to say no. Someone thinks it's their job to stop progress when what you want is progress. How about this person up here? I know several of you in the room right now are this person. You're the application architect. And better yet, you're facing the wrong direction. But you are on top of the blob. You're trying to surf the blob, hoping, prayfully, you're praying that maybe you can deploy this thing. Who is this person down here? Well, for our developers in the room, I'm here to tell you this is the operations person being crushed under the weight of this big old thing we've created that no one actually really understands. But it's because of this that we can only suffer this pain and deploy every 3 months. It's so hard to do it that we only deploy every 3 months. We get the blob pushed uphill 3 months at a time, 3 months. And for some of you, you're like, 3 months? We're way faster than that. We do it in 2 months. Some of you are even faster than that. You're like, we do it in 1 month. But it's a different model. And the new way of working, it's every week, every day, not every month, okay? Because software development and software production, a push to production should look like this. A small team working in the same direction, moving that nice rolling boulder uphill. It's still going to be hard, right? Production's not easy, but at least we can kind of make it easier for those folks. We can tear down that wall of confusion, and we can basically have dev and ops work together. And the way I like you to think of it when it comes to my warrior imagery, we all are superheroes in this story. In other words, we all have common interest. If you look at my Harry Potter over there, it's not that the ops team are a bunch of wizards. You might think they're a bunch of wizards because they do some magical stuff. But it's actually not magical. It's just actual technology that involves things like Linux and Kubernetes and networking and storage. Nothing weird. It's just called computers. And as a software developer, you probably remember how computers work, right? It's still the same thing. It's still a computer. Nothing really has changed. It's just done a different way. And so they're not actually a wizard. They just love Harry Potter. And I guess what? As a developer, you probably do too. And I'm not saying my DBA is The Walking Dead. I'm saying they love The Walking Dead. They're not a zombie. So that's really my point here. Our UX team is obviously Black Panther. You get the point? But it's actually more than this cast of characters. It's a bigger group of people. You have to think inclusively about bringing all parties into your organization and helping you build better software faster. That's a key element. It's a mindset that you have to break from the old world to move to the new world. And that's what I talk about with DevOps. And if you can break that mindset, so you build it, you own it, you code it, you run it, we work together to deliver the software together, we will all be better off as software developers and a much happier place. Now let's talk about deployment interval very quickly. That was one of my 12 ways as well. If you live in a world where you deploy every 3 months, okay, every 3 months, you guys are consistent. We build it, we deploy it, we user acceptance test it, we plan, we do everything right. We have our 3-week sprints, And we do multiple 3-week sprints, and boom, we deploy that big old monolithic thing at the end of those, 6 of those 3-week sprints. You're good at it. But the problem is, the new way of working is faster than that. You have multiple iterations now within that 3-month cycle. So it looks like this. If you deploy every 3 months, you can build a trajectory that looks like this one. If you deploy every week, you can build a trajectory that looks like this one. But the point is, one team is learning faster than the other team because you can only learn when you're in production. You can actually only know if that product and that technology is good until it lands in production. That's my point with all of this. Getting to production the fastest is the only way to learn, the only way to test, the only way to validate that you did something right for your customer. And with that learning, you can iterate faster. Okay? So that velocity to production is critical. So those who are unaware they're walking in darkness will never seek the light. So I'm trying to shed some light for you today. Now here's the nature of your application. We were able to build applications with Java EE for many years. I'm an old school J2EE person, Java EE person. We could build that application, we could put our wars in our ear, and we could deploy that thing every 3 months, every 6 months, every 18 months. I've definitely worked on projects that were every 18 months deployments, as an example. But the problem is now we're thinking about this application as a bunch of modules, a bunch of components, a bunch of microservices. And it gets weird when we start taking those microservices and we start spreading them across a network and putting a network connection amongst them. And we might have other databases involved. Instead of a monolithic database, we now have several databases. We have multiple points of entry. Therefore, we have to think about our API governance, API management. We have to think about our multiple teams with their multiple pipelines because we have now independent teams deploying these different microservices. And of course, all these principles apply to really doing microservices well. And I can tell you that these tests are incredibly hard to overcome. Everyone says they're doing microservices. Almost nobody can actually adhere to all these rules. Okay? In other words, they've redefined microservices for themselves, but they're not really doing microservices. They're just doing something that looks like microservices stuff. Okay? Now, the old school, though, was easy. We could get our arms around it. New school is tricky. And therefore, that's why I'm advocating for something like a Kubernetes being evolved in the new way of doing things. Because with a microservice, you have this distributed computing model. You have an application running in a JVM who has to talk across the network to another application, also potentially running in a JVM. Okay? The problem with that is the fallacies of distributed computing. The network is certainly not reliable. You guys have been in a conference center for the last couple days. The network is not reliable, right? Latency is never zero, and bandwidth is never infinite. So what happens if a failure occurs in this mesh of services? Well, you don't want it to be a cascading failure. That's what you wanted to avoid. You're going to have failure. People are deploying every day. They're deploying with their own pipeline, independent teams. You build it, you own it. Failure is going to happen. So the question is, how do you recover instantly from failure? That's the more important thing. Again, a different mental model. You don't protect yourself from failure. You know failure is going to occur and build all the right infrastructure to ensure you can respond to it correctly. So think about all these microserviceilities here, right? Discovery mechanisms, invocation, elasticity. Is it called resilient? Do I have a pipeline? And you can kind of see right here, we have Kubernetes that fulfills many of these things. OpenShift, which is Red Hat's distribution of Kubernetes, does more on top of that. Okay, it's our distribution of Kubernetes. And then you have Istio, which does even more on top of that. And we'll show you a little Istio in a second. Okay, so really this is where Istio comes into play. So if in the old world, you would actually build an application that looks like this, right? You would have your service discovery, load balancer, resiliency mechanisms, metric capture, tracing, all inside your application logic, all inside your JVM. Super simple, and it worked really well. We saw that model from Netflix back in 2012 was when they open sourced that technology, and that's where we learned about these cool things like Eureka and Ribbon, Hystrix, and it's all amazing. You probably use some of these libraries today. Okay? You might use them through a Spring Cloud annotation. It might be just something you just take the jar file and use it yourself. But that is definitely a model that works very well. But in the new way of doing things, we now have this sidecar called Envoy, which is part of Istio. And the sidecar can absorb a lot of that infrastructure logic that's not really part of your business logic. Your business logic is not to do lookups or load balancing or circuit breaking. Your business logic is to take data from the user interface and API and write it to a database, right? Perform some transformation on that data and take it out of the database and send it back. So now you can use the infrastructure like Envoy and Istio. So this is the Istio control plane. Hopefully you guys saw something like this earlier in Sergey's talk, right? And he talked about Istio. But the concept is actually very straightforward once you get your head around it. In the data plane, this is where your transactions flow. You can see there's HTTP 1, HTTP 1.2, gRPC, HTTP 2, I should say. And then you can see it just basically makes those invocations from Envoy to Envoy to Envoy. okay? From sidecar to sidecar to sidecar. That's what's happening. Then there's a control plane, just like Kubernetes is architected. Kubernetes has worker nodes and master nodes. The master nodes are the control plane. That's where your etcd sits. That's where your API server sits. That's where a lot of components sit within the Kubernetes architecture itself. And Istio adds some more capabilities, specifically like Pilot, Mixer, Citadel, for doing things like MTLS, for doing like policy enforcement, for doing like routing logic. We'll show you some routing logic changes. And then you also have observability. Because if you have this mesh of services, all these different services that are part of your application now, how do you know which one's acting up? How do you know which one's misbehaving? How do you know which one's slow? You got to have that information. So your observability, your tracing, your monitoring is incredibly important. I mentioned Kiali here, and I'll show it to you in a second, because Kiali is a project that we at Red Hat have open sourced and actually donated to the upstream Istio community. So this is actually a very cool console, so you can see your mesh of services and interact with them in a different way. You can get a feel for the health of those different services across your mesh. Okay, so showing off is a fool's idea of glory. That means let's go do a demo. All right, let's go try something here. Let's see if we can break something else. You guys ready? Okay, good. That's still running. So I actually have a little application here. It's customer preference recommendation, kind of like an e-commerce thing, right? You have our customer component, which talks to the preferences component, which talks to the recommendation component. I have recommendation v1. I always like to show the pod identifier. You can kind of see that right here. So that is actually the host name. If you go look at the Java code, it says, what is my host name? What is my computer name? The computer name is the pod identifier, because that is the computer from the JVM standpoint. So I have 3 computers running here, 3 pods, and I have 3 microservices, right? 3 different JVMs. Notice also the 2x2 here. This is what's unique about an Istio solution versus regular Kubernetes. Regular Kubernetes is 1x1. Meaning one container per pod. In this case, I have 2 containers per pod, and we can explore all that. But for now, let's deploy a second version. Okay? So we're going to deploy a second version, and this is another one where you guys can play along with me. So you can go over here to bit.ly 25/2019. Let me bring this one up over here. And when you bring it up, it's going to give you the same thing you see happening in my curl. See right there? So customer preference recommendation v1. And I'm deploying v2 right now. It's rolling out. And then you'll notice and actually see it's flipped over to v2 now. So if we look right here, you kind of get 50-50 load balancing out of the gate. So this right here is just default Kubernetes. You deploy a pod, it belongs to a service, and load balances for free. So you don't have to basically spend a ton of money on big IP. You get load balancing for free. And so here, I'll bring this back up again and let you guys see it. Okay, so you guys should have something that looks like this, right? Some of you are getting v1 with if you hit refresh, you might get a version 1. If you hit refresh, you might get a version 2. Does it make sense so far? And again, there's no work to be done here. That's just something you get out of the box for free at Kubernetes, is the service discovery, the load balancing, all for free. Okay, so where you might have had a Eureka, you might have had a Ribbon, you can still use those things, but it's just out of the box. You don't have to have that in your infrastructure any longer. It's part of this Istio capability if you choose to use it. Okay, and then sorry, it's part of your Kubernetes capability if you choose to use it. This is raw Kubernetes. All right, now let's have a little fun with it. You guys get connected? Who's got connected here? Just wait, All right, fantastic. So we're gonna actually have a little fun with you. Okay, so actually now everybody goes to version 2. I just flipped you all to version 2. So think about it like this. We're practicing every minute deployments now, right? We're forget that 3-month deployment interval. We're so fast, we deploy every minute. Every git push you commit, right, deploys. We're practicing hardcore CI/CD. So version 2 is now in production. That's what I just did. And someone might say, I don't want version 2 in production. That's not what I wanted. Someone might say on the networking side, roll that back. Okay, so that's easy. We are a blue-green deployment. We just rolled it back to version 1. Now you're all in version 1, right? Anybody still on version 2? So it was just that simple. That's a blue-green deployment. You have both in production, and you just simply tell the users where you're going to send them, 1 or 2. And it's very straightforward. You can see right here, we're all on v1 now, and we're going back and forth. And I have these all scripted just so we can make sure I don't type anything correctly. And now check this out. Now I'm doing a canary deployment. Now we're not doing all or nothing, blue or green, 1 or 2. Now I'm doing 10% of my users will see version 2. So 10% of my transactions will see version 2. There's one right there going by. Let's see if I can get one in my browser. There's one right here. But 10% of our transactions, if you hit that button fast enough on your phone, you may see a version 2 in there as well. Because 10% of the transactions now have version 2. Okay, let's do this. Let's clean that out. We cleaned that out, and now we're back to round robin load balancing. 1 and 2 and 1 and 2. Now notice that based on which ones you're getting, I may not get that. Okay, so you might be getting my 1 and I'm getting your 2, but you're going to get 50-50 load balancing now. There we go. Okay, so let's have a little more fun with it. Let's actually deploy now a canary deployment, a different type of canary deployment, where it is basically all users get version 1, except for some users get version 2. And this is actually probably the most powerful aspect of this. Let me go over here to my Safari. Okay, and you can see Safari gets version 2. So you can actually look at HTTP headers with Istio and decide what your routing logic should be, your routing rules should be. This means is you can have users who are logged in, and those get version 2. You can have users who are logged in and check the beta tester box in their profile, they get version 2. Or better yet, a common approach that I've talked to about with several different customers is that they basically roll out the new version to employees only, and only employees who are logged in get version 2. Customers don't see version 2. Or better yet, maybe I only want version 2 for people in New Zealand. You may have heard this from me before, but that's actually a common strategy, is to basically roll out the next version in New Zealand long before it hits the US. Different time zone, but a similar kind of apparently buying structure there. So now I have version 2. You guys probably don't have Safari on your phone though, right? Does anyone have Safari and get a version 2? You might? Okay. So you have to have that configuration, and you can set it up so that it might be mobile or otherwise. So now we do this. Let's do, okay. That's the curl, so you can see with a Safari header, you get version 2. With the Firefox header, you get version 1. Let's do this, okay. Clean out our canary. And notice I'm basically deleting these things called virtual services and destination rules. One thing I should show you is that by default, you have a Kubernetes installation, and you have things like deployment, pod, replica set, service. Those are built-in objects to Kubernetes. The thing that's new about Kubernetes is this concept of the CRD. So I basically typed in kubectl get CRD. That's your custom resource definition. And now you have all these other things that are available to you that are basically extensions to the Kubernetes model. It all works the same way. You treat them like whole objects. Like they're no different than a deployment, no different than a pod. It's just that they have custom controllers that execute based on your manipulation of those object types. And that's really what Istio is doing. Let's do this. OK, let's go back to polling. So that's why you see the virtual service was deleted, destination rule was deleted. Let's do a dark launch. OK, check out this dark launch concept. So let's say you have a situation where, let me bring up my browsers again. Okay, all version 1, and on Safari we should be version 1. But look what's happening here. My logging is also showing that version 2 is being exercised. So this is a situation where we were doing kind of a canary rollout, but nobody sees it. Everybody here is on version 1. All my users are on version 1, yet version 2 is still being exercised. Now I can monitor its behavior. I can look at it from the perspective of the monitoring capability. Like I can look at it in Grafana. I can look at it with Prometheus. I can look at it with Kiali. I can look at the transactions happening here with Kiali as an example. And then I can know what you can see, right? Traffic is going to 1 and 2. But if 2 was acting up, if 2 was throwing out 500s, if version 2 was basically eating all the CPU or eating all the memory, I could know that, fix that before any of my users even saw the error. But this is a different way of thinking. I'm now testing in production. I'm moving so fast, I don't have time to test pre-production. I'm running it into production, doing a dark launch against it, and seeing how it behaves. Now, this is obviously easy with a read-only transaction, which is what we have here. If you have a write transaction, you got to get more clever. I've worked with customers on that style of things too. It gets pretty interesting when you do writes. You have to have clever ways of handling it. But this is a simple use case in this case, right? To kind of see that. Let's see here. What else can we do to this thing? Let's mess with it some more. Okay, so that was the dark launch. Dun, dun, dun. Okay, let's clean off the mirror. That's called a mirror in the virtual service concept. So now we cleaned it off. We're going to go back to round robin 1 and 2, 1 and 2. Standard Kubernetes behavior there. And let's try this. Dun, 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 dun. I'm going to actually make number 15. The script here basically says, what happens if we roll version 2 out and it actually does misbehave? Okay? So in this case, we've gone into the code for version 2, and we basically said, hey, you're just throwing out 500 errors. The programmers who did version 2, right, they're practicing their CI/CD, but they didn't have good enough testing in their automation, and they actually did release a bug into production. You can see it right here. There's the 503s. Well, with Istio, I can do some clever things, right? So now I can work my way around that issue. okay, by this retry rule. So I'm still operating this application in production, but now what I've done is, until the programmers go fix that error, I can route around it. So my users are no longer seeing errors. So there's all these clever things you can do with advanced routing logic, monitoring capability, observability that are part of the Istio service mesh on top of Kubernetes. They give you these really fancy ways to deal with these things, but you only need these things if you're moving super fast, okay? If you're deploying every 3 months a big old monolithic application, I'm telling you this is overkill. You don't need all these fancy tools. But if you're trying to deploy every week, every day, every Thursday at 9 a.m., because that's the new way of doing it, by the way. You don't deploy Friday night like I used to. You know, you deploy on Friday night, you work all day Saturday to have it ready by new business on Monday. Anybody used to deploy that model? Still do? How many still deploy on Friday night just so they can have it ready by Monday morning? Anybody still do that? Oh, good. So, you know, that was an old school way of doing it because you had downtime the entire weekend, and the development team and ops team might be on call all weekend until the production was up and running. In this case, I can deploy it middle of the day on Tuesday during the regular business hours because I have all these safety nets in place. So let's see here. Dun, dun, dun. Let's undo that misbehavior. Okay, so in other words, we'll roll a version 2 out that doesn't have the error in it, so version 2 is good again. Okay, and let's see what else. Oh, and you can even have a slow situation. Now, this is tricky. Watch what's happening here. You can see it's killing my old version 2, redeploying a whole new version 2 image. Notice what happens up top, though. Everybody's on version 1, while this rollout, I'm doing a live rolling update. My users are still okay, and I'm getting a whole new version pushed into production right now with version 2. And when you see it go 2 by 2, you'll see version 2 show up there now. So there it comes. But look what happens. You can also tell by the number 1 and number 2 that it recycled the whole JVM, right? So that's just an instance variable. That's what I use that number for. But look how slow it is. So this is a situation where there's no errors, because the most insidious problem in a microservice architecture is when you actually have a situation where things are just slow. It's a slow database, it's a slow cache, it's a slow bit of code because we didn't handle the thread pool correctly. We didn't use our try-catch finally correctly, and we have thread pools getting out of whack. So how do you deal with that one? Let's see if we can fix that one too. You can add a timeout rule and another feature of Istio to basically say, I want to work around that issue, but look what happens. In other words, I am not going to wait on that thing for longer than 1 second. It takes too long for that transaction to occur. I'm going to time it out before I have to wait. So this is a circuit breaker. This simply means now in my fallback just simply shows the user the error, but I'm not waiting any longer because I have a service level agreement that says I have to respond faster than that. Okay? So there's just lots of kind of fun stuff here. Let me just kind of fix that up. And let's see here. And of course, it'll redeploy a proper version 2 back out there, and then you'll see it load balancing again. So see it go through its deployment cycle here. Okay? And again, all this is running, and you can see on my monitoring, by the way, you can see I was getting errors. Okay? It was telling me, hey, there was problems here at version 2. It was misbehaving. So use your monitoring tools to basically know what's going on. So that's your observability tools that are part of this. How does that sound pretty cool? Pretty interesting? Okay? So that's Istio on top of Kubernetes. Let's kind of rock and roll you through some more things. And then we'll kind of wrap things up because we're almost out of time. So that was my showing off a fool's idea of glory because I let you guys run the application. We could have caused all kinds of havoc in that case. Now, be happy but never satisfied. Another great quote. And here's the point. It was all cool that we did all that fancy microservices stuff, but we're now in a new world. Forget microservices. We want to do serverless. We want to do functions. That old school microservices, that's like 2012. It's 2019. Let's try something completely different. Well, it doesn't have to be completely different because there's another technology, and we're going to talk about it in a second, called Knative that sits on top of Istio and Kubernetes that gives you yet more capabilities. Okay? So the first question when you're living in this world is there a service that I can consume, one that I can use? What that means is I'm not going to rebuild a database engine. I'm going to use a database engine. I'm not going to rebuild a custom cache. I'm going to reuse a cache because it's serverless because you're borrowing other people's services. That's the way to think of it. Some people use the phrase, instead of serverless, think serverful. Okay? All these other services I'll be using because it's all about the services. I need an API gateway as a service. I don't need to rebuild an API gateway. I can, right? You can use Lua and your own Nginx, and you can go crazy. Somebody here has probably done that already. In other words, you're not Java programming anymore. You're programming in Lua and Nginx, and you built your own API gateway. But there's plenty of API gateways out there. Why build one yourself? Maybe you want to build your own SSO. I was just talking to someone yesterday. They built their own SSO solution. Okay? But guess what? We now have things like Keycloak and open source. It's an SSO service. You just stand up the service and use it. It gives you JSON Web Token and SAML and things like that. Or you can just use one from one of the cloud providers. Maybe storage as a service. Do you guys want to write your own S3? Well, a globally hosted storage service that also has a CDN is actually hard to build around the globe. Why not just use one that's already out there? Maybe I want to build a cache. No, just use a cache. Maybe I want to have a database. Just use a database. There's plenty of good ones at open source. Maybe I want to build a message broker. And guess what? I know some of you guys have worked for a big bank, and for some reason that big bank felt the need to write their own message broker, didn't they? Okay? Because we use Java. Just like we used to build our own MVC framework, we now build our own, message brokers. Why would we do that? There's plenty of them out there in open source. You can also use them as a service. Also, push notifications. Things like SMS messages or sending push notifications to Apple or Android. Don't rebuild that code. It's not hard to write that code, but why not use it as a service? Then you start filling in the components to make up your differentiating business logic. Focus on what makes your application unique, your business unique, not another database vendor. If you are a database vendor, then build that. But if you're a business, build your business logic instead. And then you could use these ephemeral functions to connect the wires together. Basically, you can use functions to connect the dots. The whole thing still makes up an application that then is consumed through an API by your business partners, by your mobile applications, by your desktop applications. So at Knative, you now have these primary components that sit on top of Kubernetes. You notice I put a red line through build. One of the things you'll see over the next week or so is that we are going to tell you that build is being replaced by another project. Okay? But by default, you have Knative serving, which allows you to scale down to 0, which is what I showed you in yesterday's presentation, and up from 0 back to something else. And then you also have eventing. So the idea behind Knative is that it's basically more Kubernetes components that are native to Kubernetes. They give you base primitives for doing middleware technologies, component-based technologies for serverless-style use cases. Okay? But these things are still useful kind of universally, serverless or otherwise. Now, it has interesting capabilities. Scale to 0. If you have no pod, because there's no load, you have no memory, and you're not paying the cloud provider that you're spending money with on a monthly basis for that memory. So just think about that a second. This is a different mindset as well. Why pay for hardware I'm not using? By default, we're doing that as software developers, and we've done that for the last 40, 50 years. If there's hardware that has been purchased, including virtual hardware in the public cloud, just keep it up all the time because we're just spending the money. But it doesn't require that if there's no load or if there's a lightly loaded service at a different time of the day. And we want to scale out. And what I showed you in the demonstration yesterday was what happens if we have to burst out based on a massive amount of load. It's easy to scale up. And we're using Quarkus, because it's fast and small, to easily scale out. But scale to 0, scale from 0. Also deal with configurations and revisions in a better way, so easier to do blue-green deployments. In-cluster image building. So instead of doing a Docker build on my local machine, I can do the Docker build in the cluster. So, because most developers probably have Windows on their laptop. Okay, some of you may have a Mac, some of you may have Linux, but that rarely matches your production environment. You may have Windows here and Red Hat Enterprise Linux over there. You may have a Mac here and Ubuntu over there, right? You may have Ubuntu here and Solaris over there. So doing the build in the cluster, in the production-like environment is actually better than doing it locally. As a matter of fact, if you are an ops person here in the room, do you really want a developer doing their Docker build? They could sneak all kinds of bad stuff in there. Okay? As a matter of fact, I could show you the images I have built. They've got CVE warnings all over them. Critical vulnerabilities and exploits are pretty much in every image a developer creates, including the ones I create. So you want to think about these kinds of concepts. How do you deal with the build? And also how to go beyond HTTP. It's an HTTP world. I respect that. But there's a lot more people who are basically saying our microservices backbone is not HTTP, like Netflix was. It is Kafka. That is happening more and more at an event-driven architecture that still leverages microservices capabilities, but uses Kafka as the backbone, not HTTP as the backbone. So that's what Knative eventing is for. So Knative serving, you can actually do a get kube control, get CRD, grep for serving. You'll see there's some new concepts there. And then, of course, you'll see there's a config map for the autoscaler. If you look at old school Kubernetes, it has this concept of a deployment that you create, which creates a replica set, which creates your pods. And of course, the service is the gateway to those pods. That's what you saw with the recommendation 1 and 2 as a service for recommendation. load balancing. That's your load balancer right there in your service. And then when you do it with Knative, though, you basically have all this other set of infrastructure, right? You have a configuration, a revision, then you have a deployment and a replica set and your pod. So this is old Kubernetes here. This is the Knativized Kubernetes now, right? And then, of course, there's this virtual service and an activator that actually help the dynamic scale up and down. Because Knative is, Kubernetes has always had auto-scaling, or at least had auto-scaling since pretty early in its inception. But it's auto-scaling based on memory pressure and CPU pressure. This is auto-scaling based on transaction load, okay? HTTP transaction load, Kafka queue depth load, whatever you want it to be, but it's actual transaction load. Knative build, as I mentioned, is kind of going away. But again, the get CRD there will show you the build objects, build primitives, so you can actually do that in-cluster build with something like Kaneko as an example. I will be doing the 3-hour version of this with O'Reilly next Wednesday. So we actually walk you through all these components. And you can kind of see that it's a process that looks like this. You might have a secret, you have a service account, you might have to pull from, do a Maven-based build, you might have to do a Docker build with a cache, right? And then you just run through your steps. And then the cool thing about it is it rolls out a new Knative service after that. It does the build cycle, and boom, pops it right into production, and then you can do your blue-green canary deployments around it. But build, as I said, is going away for this project called Tekton. Just be aware of that. Follow this one. It has a whole new foundation behind it, a whole new open source project. The fellow who's moving the build concepts into Tekton works for Red Hat. His name is Vincent, so you'll see him out there on GitHub talking about all these things. And this last piece, though, is very important to understand. Knative eventing, you have the ability to do things like GitHub, like what happens when a pull request is submitted. Maybe I want WebSockets, again, not HTTP. Maybe an Amazon SQS, a Google Pub Sub, Apache Kafka. So Red Hat is working on the Kafka one and the Camel one. And the cool thing about the Camel one is you will see that it has Camel, talks to everything. So the point of this is, I want to talk to things that aren't HTTP. How can I do that? And maybe Camel's the answer for that, okay? And so eventing is another thing. So we are at a time. You guys do have access to the slide deck, bit.ly 12 Ways Cloud. There's the live training that I'll mention only because when you come into the live training, you'll see that I have a lot of different live training classes. Again, like the Istio one, which is a 3-hour deep dive, Knative, which is a 3-hour deep dive on top of the base Kubernetes stuff. You have other things like the Istio tutorial. These are documents we've put out there as ebooks on GitHub. As an example, the Knative tutorial. All right, and then of course there's different blogs and things like that. So there's all the information you could possibly want to figure out how to set up this on your local machine or even in the public cloud if you wanted to. Again, there's a couple of free ebooks. I mentioned the Istio book that I worked on, and we've now just published a couple weeks ago. So the Istio book has now been refreshed and has the new information. This is also a book to help you deal with techniques for dealing with a monolithic to microservice database movement. So if you want to move from monolithic applications and monolithic databases to a microservices application architecture, and of course that principle of every microservice owning its database, this has a lot of tips and techniques. So Edson Yanaga on my team worked on that free ebook. And then, of course, just general microservices. This is more your Spring Boot, your kind of traditional way. Here's your reactive way using something like Vertex. And I mentioned all those advanced materials. And so the last thing here, because we're out of time, is don't fear failure. Not failure, but low aim is the crime. It's great, in great attempts, it is glorious to even fail. So in this new world, I'd encourage you to go out and try these cloud skills, right? Come out here and figure out how you're going to learn one cloud or another, and actually learn multiple clouds. Do not get married to one cloud or another at this point in time. Figure out if I can actually deploy something in India on Google, and Azure in the case of California, or Amazon in the case of Frankfurt, things like that. Well, did I move fast enough for you guys? Okay, I know we're into a coffee break now, but do you want to try a couple questions? Okay? Yeah, so he can throw the microphone and hit you in the head. You can ask me a question until they tell us, well, we're into the coffee break too far and we gotta take a break. But what'd you guys think? Was this interesting? Did I talk too fast? You can say that. I do talk too fast. I'm sorry. And it's actually normally not a problem here in this part of the world, but the Germans always tell me they don't understand me. Yeah, so it's only when the Germans like, you talk way too fast. It's kind of a consistent thing. It's like, I don't know why. Maybe when you speak English in German, or in Germany, they speak it a lot slower. Okay, but any questions? No? I will be available afterwards. You guys can certainly feel free to come up and hit me up later. But do make sure you get access to the slide deck, because there will be lots of questions. You can see there's tons of links in here. So let's come here and come here. So this link right here is the one you'll want. The bit.ly 12 Ways Cloud gets you access to all the slides, along with all the links, which takes you to other slide decks, other presentations, recordings, ebooks, links to the O'Reilly Safari Live content. All that can be available to you, and you guys can start learning this technology. Well, thank you so much for your time. And if you have questions, I'll be available afterwards. Thank you.
Thank you. Thank you, Burr. Thank you, guys. Now it's time.